Hi, everybody. My name is Bill Troutman, and this is the section on infinite limits for Calculus 1. So, infinite limits mean we can say a limit exists if a function approaches infinity or negative infinity. If it meets all the other requirements and it's actually approaching like both from both sides, negative infinity or positive infinity, we can say the limit exists. In the past, if we just say if a limit is approaching infinity or if a function is approaching infinity, we say the limit does not exist. That was one of the stipulations for limits. However, if we call them infinite limits, so we're calling infinity like a number now, a solid number. So if we say we're dealing with infinite limits, then the limit does exist. And we can write it down. Maybe it still doesn't, but we can write it down as a solution, as an answer. We can write the actual answer down. Just looking through here, making sure. Oh, it looks like a mess. Oh, the functions are okay. There's some double. All right, so let's take a look at the first limit. What is this limit? The limit as x approaches 2. So here's our function. Once again, if you just plug 2 straight in there into that function, you get undefined. So when it equals that number, there's an undefined. So we want to know what this limit approaches. Once again, the nomenclature here, the way it's said is x approaches 2. X gets very close to 2. Except I can't spell. It's not letting me write. So anyway, x is approaching 2. That's how you would say that. So let's get very close to 2. I'm going to just do a t table really quick as x approaches 2. And I'm going to say as x approaches 2 from the left side. In other words, if you look at a number line, here's 2. From the left side, as we get closer and closer to 2, I can call this 2.1. I can call this 2.01. If you're looking at the scale, I can call this 2.001. So let's first put 2.1 in this function and then 2.01. Then if I want to get crazy, I can put 0.0001 and see what I get. So I do 3 divided by 2.1 minus 2, and I get 30. So then I'm going to do the next one, 3 divided by 2.01 minus 2, and I get 300. You see here's one decimal, there's 2 decimals. This would be 1 decimal is 1 0, 2 decimals is 2 zeros. 4 decimals would be 4 zeros. So if I did 2.000000000000001, I'm getting really close to 2. We're approaching 2 from the left side of the number line. Getting very close. Here's 2. We're getting really close to 2. I may get 3 million there. In other words, from the left, as we get closer and closer to 2, do you see how we're approaching infinity? We're getting closer and closer to infinity. We started with 30, 300, 30,000, 3 million. If I get even closer, I'd go to 3 billion, 3 trillion. So we're approaching infinity. Let's try it from the right side now. So once again, here's my number line, here's 2, but I'm approaching 2 from the right side. Oh, I already approached it from the right side. I apologize. Well, you get the point. I was thinking of a negative number. 2.1 is on this side. It's the same concept. So now I'm approaching it from this side. Oh, I should have put the whole number line so I see 0. 1. So I'm going to get really close to 2. I'm going to go to 1.9. Do you see? We're getting really close to 2. Then I'm going to get closer to 2, 1.99. I'm going to get really close to 1.9999999999999999999. So let's see what happens if I put 1.9, 1.99. I'm getting really close to 2. 1.9999999999999. So let's see. I'm going to put it in my calculator. 3 divided by 1.9 minus 2. And I get negative 30. Then if I do 3 divided by 1.99 minus 2, I get negative 300. Then if I put in a whole bunch, I get negative 3 million. And then if I put even more, 0.999999999, I get negative 3 billion. Do you see, as we get very close to 9 from the left side, it's approaching negative infinity. So if they both approach positive infinity, then the limit would be, for infinite limits, then the limit would be positive infinity. But since from the left and the right, they approach 2 different numbers, and this is from the right, sorry. This is approaching from the left. Since they approach positive infinity and the other side approaches negative infinity, then the limit does not exist. But if they have both approached infinity, if they both approach negative infinity, then the limit exists and it would be positive infinity or negative infinity, whichever one it would be. Okay. So let's try another one. Here, this is the same thing that we just did. As we approach 2, and if there's a minus sign there, if we approach 2 from the left, that negative means we're approaching 2 from the left. If we approach 2 from the left, which is down here, we ended up with negative infinity. If we approach 2 from the right, we ended, 2.1, 2.11, 0.001, 2.0001. We get positive infinity. So if we just had this, if it said infinite limit, what does this limit equal? The answer would be negative infinity. If we just had this limit, and in the problem it says we're dealing with infinite limits, then the answer would be positive infinity. But since we're asking in the previous problem, what does the limit equal when it approaches 2? Since it approaches 2 numbers from different sides, then this limit does not exist. 3 over x minus 2, okay? So once again, if you just do it from the left, it exists. We can write that answer down. We don't want to say it exists, but it does have a limit. If we approach it from the right, it does have a limit, but the whole thing doesn't have a limit. You can't say the whole thing has a limit because it approaches 2 different infinities. One's positive, one's negative. Oh, so let's take a look at this. And I'm going to do this one on my calculator rather than plugging in numbers like I did. So let me put that in my calculator first. 1 divided by x minus 1 squared. So I'm plugging this into my TI-84. And I want to get really close. Once again, the limit approaches 1, and we're going to start from the left. Approaches 1 from the left. If you draw a number line, here is 0, here's 1. If I approach 1 from the left, I'm getting really close to 1, 0.9, 0.99. Do you see? I want to get closer and closer to 1, but not touch it. I'm just approaching it. So I want to look at what that equals if we get really close to 1 from the left. And I'm checking my window, and then I'm going to graph it. If you look, here's 1 right here. As I approach 1, x1 on the graph goes up to infinity. You see, the closer I get, the higher it gets. So as I approach 1 from the left, the limit goes up to infinity. If I approach the limit from the right, this function from the right, I'm looking at 1.1, 1.001, 1.00001. We're getting very close to 1 this way. And I just messed up my... All right, so if you notice as I approach it from the right and I'm moving towards 1, here's 1, it goes up to infinity also. The graph goes up to infinity. So since the limit from the left approaches infinity and from the right it approaches infinity, and we know this is labeled an infinite limit, we can say the limit of this function, since it approaches from both sides, from the left and from the right, the limit approaches infinity. So we don't say it does not exist. It exists and approaches infinity. Vertical asymptotes. Vertical asymptotes are lines on your graph you cannot cross. To find a vertical asymptotes are vertical lines. Your graph. Sorry, it's not letting me write. Your graph cannot cross. So if we look at this graph on a calculator, where do you think the asymptote is? The asymptote is whatever makes the bottom equal to 0. And if you look, 2x plus 1 equals 0. If I divide equals 0, if I divide by 2, nothing happens. I get x plus 1 equals 0. If I subtract 1 now, x equals -1. So on our graph paper, x -1, there should be an invisible line that your graph cannot cross. So I'm putting this graph on my calculator. 1 divided by 2, x plus 1. So I'm putting that function, if I can get it to focus, there we go, in my calculator. And when I graph it, do you notice at x equals -1, there's an invisible line you can't see that the graph cannot cross. Do you see from the left it goes down to infinity, from the right it goes up to infinity as you're approaching -1, but it doesn't equal -1 because we have an asymptote there. And you can actually look at your table, and do you see at -1 it says error because -1 makes the bottom of that denominator equal to 0, which makes it undefined. And you can even see from the left, it's getting higher to the negative. It's approaching negative infinity if we get closer and closer here. From the right, as it approaches -1, the numbers are getting larger and larger, approaches positive infinity. So all we're doing is finding the vertical asymptotes, and the equation for all vertical asymptotes are x equals. So this is the answer. Let's find the vertical asymptotes here. We factor the bottom, x plus 1, x minus 1. So the bottom cannot equal 0. So x plus 1, the bottom cannot equal 0. So x plus 1 cannot equal 0. Or x minus 1 cannot equal 0. So there should be an asymptote at -1, and there's an asymptote at 1. And I say start verifying these things on your calculator. I'm going to type this into y equals parentheses x squared plus 1 divided by parentheses x squared minus 1. And if you look at, that's the function I typed in. If I hit graph, if you notice, there are two asymptotes. One here at -1. Do you see there's an invisible line that your graph cannot cross? And there's one here at +1, an invisible line you cannot cross. We're trying to approach it, but we can't cross it. That's what an asymptote is. If you look at the table, at -1 we have an error undefined, and at +1 we have an error undefined. But as you're moving towards -1, the numbers get larger. They go up to infinity. And if I scroll down a little bit, as we're approaching here, do you see how the numbers are going up to infinity here? And if we got really close, you'd see that these numbers would be approaching negative infinity. You see, as we approach from this side, the graph goes down. As we approach -1 from this side, the graph is going down to negative infinity. So finding the vertical asymptotes, we found them. Those are it. Find the vertical asymptote for this function, cotangent. The easiest way is to change it. You have to know what cotangent equals. Tangent equals sine over cosine. So cotangent equals cosine x over sine x. So where are the vertical asymptotes? Wherever sine x equals 0. That's where the vertical asymptotes are. Wherever sine x equals 0. Break out your unit circle. Remember, you're allowed to use this on the test. Wherever sine x equals 0. And here's the unit circle I posted in the in the module that you can use on the test. And we're saying where sine x equals 0. Sine is the y aspect, the y part of the coordinates in the unit circle, sine. So where is the y equal to 0? Right here at 0. Uh-oh. What did I do? Right here at 0. Sine of 0 is also at pi. So it's at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Those are all where the sine or the cotangent is undefined, or there's an asymptote, or where the asymptote exists. So find the asymptotes. There's one at 0. There's one at pi. There's one at 2 pi. 3 pi. And so on and so on. One way of writing that, let's see if we start at 0, it's n plus pi. I guess you could write it n plus pi and call this n equals 1, n equals 2, n equals 3. See if you, oh, actually, maybe I should put, I'm trying to figure it. Well, there's got to be, if I start at the negative 1, I guess, but anyway, well, I'm going to start here. If n is 1, we're at pi, n is 2. You'd have to write it another way. There's got to be an easier way to write this. I'm sure there is. Okay, so there is, it's not n plus pi. We should say n n times pi. That makes better sense. And we'll use where n, these are not n is an integer. So we could use 0. If we plug 0 in there, we get pi. If we plug 1 in there, we get 0. If we plug 0 in there, we get 0. If we plug 1 in there, we get pi. 2 in there, we get 2 pi. We also can plug, another integer, -1 in there, and we get negative pi on our graph. So let's graph this cotangent y equals, on your calculator, there's no tangent. There's no cotangent. But cotangent is the same thing as the reciprocal of tangent. It's not inverse tangent. It's the reciprocal of tangent, or 1 over tangent. So when I graph it, you can see the asymptotes. There's an asymptote at 0. We already said, do you see how the graph gets really close to 0, x0? And then there's one right here at 1, 2, 3.14. Do you see at pi? And then at 6, 1, 2, 3, 4, 5, 6.2. There's another asymptote at 2 pi, then 3 pi. At -1 pi, right here, -2 pi, -3 pi, and so on and so on. Once again, it's really good to visualize these on a calculator. Find the vertical asymptote here. I think this is kind of important. So let's find these asymptotes. And we already said what makes the bottom of the fraction equal to 0. Well, I have to factor that bottom, x plus 2, x minus 2. That's the factors. So x equals -2 and x equals +2 are my asymptotes, vertical asymptotes. Let's verify that. By the way, that's not a true statement. I know I don't have two asymptotes here, but I factored it out and it looks like I have two asymptotes. So let me type this into my calculator so we can see it and then we'll talk about it. X squared plus 2x minus 8 divided by x squared minus 4. So I typed the two functions into my calculator and hit graph. I should have an asymptote at -2 and +2. Look, there's an asymptote at -2. 1, 2. There is an asymptote. But at +2, there is not an asymptote. Let's look at our table to see. Second table. I'm looking at my table, and at 2, there's an error, and at -2, there's an error, undefined. So at 2 and -2, it says undefined, but I don't see the asymptote on the graph. I don't see the +2 asymptote. I see the -2 asymptote. It's because if you look at the top, we have to factor the top also. So the top factors to x plus 4, x minus 2. If I factor the top, do you see how the x minus 2's cancel? So 2 is still undefined, but it's not an asymptote. What it is, -2 is an asymptote because it doesn't cancel out with anything above. 2 is not an asymptote. It's a hole in our graph. And holes we call removable. It's a removable discontinuity. So make sure you write this down because this is the homework, and on the test they're going to say, are the discontinuities removable or non-removable? An asymptote is non-removable, but a hole in a graph is removable. So I just said a hole in the graph. This is going to be really hard for me, but I'm going to try it. I'm changing my settings to see if I can find the actual hole at 2. I'm going to change my settings to see if I can actually see the hole at 2. I'm going to get very close to 2. I'm changing my windows. On the x-axis, I'm going to 1.999. That's my minimum. I don't know. Let's start at 1.9. I don't know if that's going to do it. 1.9, and I'm going to x max is 2.1. And then I'm going to lower this a little bit to -3. And let's see what my graph looks like here. And do you actually see at x equals 2, +2, there's a hole. So you actually see the hole in the graph, the discontinuity. This is called a removable discontinuity because the hole is gone. The other one, the asymptote, is called non-removable discontinuity. So I actually see the hole at 2. If you get close enough to it on your graph, you also will be able to see it. Just take some practice changing your settings. Some of my students in the face-to-face class were using the zoom in features on the calculator. Yeah, and I don't know how to do that. I just changed my window till I see the hole. Okay, so now we have one vertical asymptote for this problem. If it says list of vertical asymptotes, the only answer is x equals -2. The other number is a hole. It's not an asymptote. Is this the same problem we just did? Oh, it popped up twice. Yes. Okay, so here's the last slide, and we're going to determine the limits. And you might have to, you can actually put this in your calculator and take a look at it. But the work, if this was a problem on a show your work part of the test, the work I want to see is we're approaching 0. Here's a number line. Here's 0. We're approaching 0 from both sides. I'm going to plug in a very small number, 0.01, 0.00000001. So let's say I plug in 0.000. I'm approaching 0. On my calculator, I type in 1 plus, I'm not typing it into the y equals, I'm just typing this in. 1 plus 1 divided by 0.00000001 raised to the second power. So I just typed it into my calculator. I'm plugging in a number very close to 0, 0.0001, and then I'm squaring it. And if I hit enter, it says 1EE6. In other words, that might be 1 trillion or whatever. It's a huge number. 1 divided by a very small number approaches infinity. It gets very large. If you divide 1 by a large number, it approaches 0. But if you divide 1 by a very small number, and then I'm going to square it, the answer becomes very large. If you go both ways, by the way, if you approach it this way, negative 0.000001, when you square it, it becomes positive. It approaches 0 also. So what I have here, as this limit approaches 0, I end up with 1 plus infinity. And if you add 1 to infinity, you still get infinity. So this limit equals infinity. This limit, it just says, and by the way, we're in the infinite limits. The problem would say, when dealing with infinite limits, or this is an infinite limit. So if I look at this problem, it says approach 0 from the right. On our graph here, 0. We're approaching from the right, getting very small. So I'm going I'm gonna put a very small number, positive number in there. By the way, if you put 0 in there or a negative number, you can't take the natural log of a negative number. So I'm going to just show you what's happening here. It's really subtle at first. You can't tell the 3 natural log x. So 3 ln, and I'm going to type in 0.1. And I get negative 6.9. Then I'm going to type in 3 ln, getting closer, 0.0001. I get negative 41. Then I'm going to do one more, 3 ln 0.001. And do you see how the trend, as I'm getting closer to 1, very close to 1, the trend is the numbers are getting higher negative. In other words, it's approaching negative infinity. The graph is approaching negative infinity. So the answer to this is negative infinity. You don't go from both sides because they only want the limit as it approaches from the right. Here, since it doesn't tell you plus or minus, that means you have to approach it from both sides, and from both sides, it does approach infinity. So these are these two limits. If you have any questions on this, please feel free to email me. Let me know what's going on. That's pretty much all I had. That was section 2.5. You guys have a good day.